Let's start a new series all about one of my favorite visualization libraries. Welcome to this video on Streamlit. My name is Kevin Fiesel and I am the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. It's time to start a brand new series, and this time it is all about Streamlit. Over the course of this series, we're going to build an application using Streamlit. So we're going straight into a demo, right? Oh, you must be new to this channel. No. We're going to the classroom. This series is based loosely on a presentation I've created called Build a Data Application with Streamlit. I guess the more accurate way of putting it is I created the talk, wasn't satisfied with it, decided to rebuild it from scratch, and also figured that, hey, I can milk a video series out of this in the process. You gotta farm those engagement points after all. So let's talk about Streamlit. Streamlit is a Python library for building and sharing data applications, which leads to the first question. What in the wide world of sports is a data application? Well, viewer who's already antsy to escape the classroom, a data application is a web-based application whose intent is to display, analyze, or visualize data. The origin of the data is technically irrelevant. It could come from a relational database, a set of flat files, some API, document database, or OCRs of images of post-it notes on your monitor that you've saved in an S3 bucket. But based on that description, it should be obvious that not all applications are data applications. Think about the kinds of applications you build or use on a regular basis. Most of these applications are essentially filling out forms. I can fill out the online TPS report generator and make sure my TPS reports are up to date. I can fill in my time into a timesheet app. I type stuff from a piece of paper into a web app so that the next person in the chain can print that out and type it into a totally different web app. These aren't data applications. These are applications that can generate data, but it's not really the same thing as what we're going to cover here. Instead, think of a data application like a set of reports or dashboards. I want to expose interesting information that I have already collected. Now, there is some capacity for interaction. I might want to let people filter, slice, sort, or otherwise manipulate the charts and tables to extract insights from this data. But we're not really creating new data here. If this data application is what you're looking to create, then Streamlit might be a great choice for you. But let me place it on a continuum to give you a bit more context. At one end of the spectrum, we have Jupyter Notebooks. Jupyter Notebooks are excellent at giving you the ability to put together something quick and dirty without having to think about a UI. You can write code, execute that code, and even generate visuals within the context of the notebook. I love these things for andragogical purposes, that is, for teaching adults, and find them quite useful as a data scientist because I can hack away at a problem in a low-friction manner. But these things are not great for handing out to end users. First off, if you just send an IPyNB file to someone, you're assuming that person has Python installed, Jupyter set up, and knows what to do with the notebook file. If that's true, great. But generally that means we're talking to data professionals or developers, not business analysts or executives. Second, even if you host your Jupyter notebook on a server someplace, a notebook is ultimately a development experience. You can have a pre-filled notebook with certain images in place, but again, that's not really the ideal experience for getting and maintaining a non-technical user's interest. On the other end of this spectrum is an application written in the JavaScript Framework of the Month Club. I chose React here because it is currently the most popular framework, but you could replace that with your framework of choice. The plus side to writing an application in a framework like React is that you have a huge amount of control over your domain. You can build pretty much any type of web application doing whatever it is you require. The downside is it takes a lot of skill, time, and effort to build one of these. And I'm not even talking about the 12,000 NPM packages you need to build Hello World in React. Sorry, had to get that jive in. But I am talking about the amount you need to know to build a web application in any major framework like this. We're talking knowledge of HTML, CSS, and JavaScript in general, not to mention the particular framework of choice and the mechanics of how it operates. Being a proper front-end developer requires a lot of skill, and I respect people who have those skills. I do not. That's why I work with data. And it turns out that most of the people who are really good with data tend not to be good with custom UI development. If you are one of those people who are great at both, good on you, but I typically am going to avoid that end of the continuum. Moving a little further in, we have web frameworks in Python. I chose Django as my example because I've built Django apps and I like the framework. You could also talk about TurboGears or CherryPy or whatever web framework you want. It doesn't even have to be Python. This is very similar to the React argument, so I won't rehash that here. But I will simply say that if you are a data scientist and you're trying to put together something quickly or create a simple application for business users to work with your data, this is probably a bridge too far. This is more for proper development of real-world web applications, and you probably have application developers who are going to build this for you. Moving a bit further in, we have Dash. Dash is a powerful dashboarding library for Python. It absolutely works, and I've seen great implementations of Dash in production. I think that this is probably where you can realistically get data scientists and data platform people on board, though there is still a bit of ceremony involved with that library. Streamlit, meanwhile, is a little bit easier to use than Dash, while still providing a lot of capability. That level of simplicity is part of why I like it so much. I can focus on getting the data right and spend less time on building an application to view my data. In that way, it's a bit like modern dashboarding tools such as Power BI or Tableau, though I don't put them on this list because all of the items that we have here are code first, so those dashboarding tools really fit in a different category. All right, let's summarize this by talking about why we might want to use Streamlit, and this time I'll do it in list form. First, we can develop web applications without needing to think about HTML, CSS, or JavaScript. If you know those already, great. But I would argue that the average data person either does not know them or has such a halting understanding of the languages that we're better off avoiding them altogether. Second, Streamlit works really well with a variety of common Python libraries. Think about libraries such as scikit-learn, pandas, numpy, and spaCy. You can easily translate pandas data frames or view the results of dependency parsing in spaCy using Streamlit. It also has great support for Python visualization libraries like Plotly, Matplotlib, and Seaborn. Third, we can quickly visualize data science projects. It won't be quite as fast as building a notebook, but I can build a simple application over the course of an hour or two, as we'll see in this series. Fourth, we have more options for interactivity than notebooks. We can include common form elements like buttons, checkboxes, drop-down lists, range selectors, and plenty more. And finally, this allows people who don't have Python installed to interact with your data, because Streamlit applications are web applications, so you just interact with them in your browser. All of this makes Streamlit a compelling option for data scientists, as well as other data professionals who need to display visuals in an effective way. Now let's go to the demo and try it out. Here we are in Visual Studio Code. I'm going to start this demo off by creating a virtual environment in Python. In case you are not familiar with virtual environments, these are a great way of isolating package dependencies between Python solutions. For example, I'm going to need to install Streamlit during this series, obviously. Well, Streamlit comes with its own set of package dependencies, and the specific versions of those dependencies might conflict with versions of packages I need for other projects. This can lead you down a real rabbit hole of problems, especially if you're developing a project locally and trying to deploy it to a server. Upgrades can also be a nightmare. If one project needs an old version of Pandas and my project needs a newer version of Pandas, we have to figure out some way to get the old project up to date or reduce the version requirement for my new project. Or alternatively, we create two virtual environments and then each project can have its own version of Pandas. I would consider that a much easier solution at the cost of a bit of disk space. At the end of the day, a virtual environment is a stripped down installation of Python. Inside that stripped down installation, we can install whatever we need for our specific project. Let's create a virtual environment here. To do so, let me make sure that I'm in a Windows command prompt. You can also use PowerShell for this, but I found that the command prompt option will be a little easier to work with, especially inside Visual Studio Code. I'll run the Python command and include the -m switch to execute the virtual environment module from the command line. Then I'll need to give the new virtual environment a name, which we'll call Demo App. That'll take a short moment and will give us a new virtual environment. By the way, if you're running on Linux, you might need to use Python 3 instead of Python here. Next up, we'll want to activate the virtual environment. To do so on Windows, we give the virtual environment name, then the scripts directory, and finally run activate.bat. What this does is, it modifies your path to include demo app folders as the first version of Python the console will look at. That way, anytime I run python.exe, it'll be this version of python.exe in demo apps/scripts. Same with pip and other common Python executables. Also, the installation directory for new packages will be in demo app/lib, so that's how we isolate package versions between projects. If you're running on Linux or Mac OS, you activate the virtual environment by typing source demo app/bin/activate, and that'll activate the virtual environment for you. When we're done, we can type in the command deactivate to deactivate the virtual environment in this console. Granted, closing the console will effectively do the same thing, as new consoles will not start in your virtual environment. Now that I've shown that, let's go back into the virtual environment again and continue on. The next thing we want to do is install Streamlit. To do so, I'm going to add it to a requirements.txt file that I've got created here in the source folder. I should note that Streamlit has some other requirements, including the PyArrow package. PyArrow allows us to do some neat things like reading files in Parquet format, so I have no qualms with including that. Now, I will be a little lazy about this and will not peg a specific version of Streamlit in my requirements file. This might come back to bite me in a couple of years, but so be it. And while we're here, I'll add a few more libraries as well. We're going to need them soon enough. And as we get further in this series, I'll come back to this requirements file a couple more times and add new capabilities. Now let's take a moment and install our project dependencies. I'll make sure that I'm still in the virtual environment. I can do that in most consoles by checking for my virtual environment name in parentheses before the directory location and cursor. I can see that I'm in the demo app virtual environment, so let's go ahead and install some requirements. And as another quick note, if you are running this on Linux, you might need to run pip3 instead of pip. That'll depend on your distribution and whether the sysadmins created a symbolic link from pip3 to pip. This will take about 30 to 45 seconds to complete, but I can move on while it's installing. Now what I'd like to do is create a file called index.py in my source folder. Let's open up that file. As we can see, it's just a blank Python script, but we're going to fix that. I'll paste in a little bit of a starter script, and we'll talk a bit about what I've pasted in here. First up, I want to note that this is just a normal Python script. This index page will act as a single page in a Streamlit app, so we can have multiple pages available to us, as I'll show a little later in the series when it becomes relevant. By convention, we import Streamlit as st. Then we can use a variety of built-in functions around Streamlit. Here I'm using the title function to add a title to a page. I'm also writing text to the screen using the write function. We're using triple quoted strings in Python to allow me to include paragraphs of text, including things like new lines. Streamlit also supports a large chunk of Markdown. Markdown, if you're not familiar, is a syntax for formatting text, and it's simpler to use than HTML. I can incorporate Markdown blocks that include headers, bolded and italicized text, ordered and unordered lists, hyperlinks, images, and plenty more. In the write function, I actually include a little bit of Markdown, as I've included a link to Daniel Hoopmacher's website, where you can grab his Chicago parking tickets database, because I'm going to use the Chicago parking tickets database again in this series. I like that dataset so much. Now that I have the basics of a page in place, I can run this app. There are two ways to do it. The first way is to run Streamlit run index.py, and then the other way is to use Python -m Streamlit run index.py. I'm going to run the simpler command because I can get away with it in Windows, though if you are doing this on Linux, you might need to prepend Python or Python 3 -m before the Streamlit command. Running this command brings up a web server that's hosting our Streamlit site. It will, by default, run on port 8501 and open up a web browser to that page, which is what you see right here. The web page is rather simplistic, containing only a title and a bit of text with a link, but we will extend this soon enough. In fact, let's extend it right now. We'll go back to Visual Studio Code and add a little bit more. This time, I'm going to include a sidebar. I'll paste this text in and save the index file. Note that the Streamlit service is still running, so I don't have to stop it and restart it. Looking at the text just a little bit, I use st.sidebar to make mention that this is something I want to show up on the sidebar. With Streamlit, we have one sidebar and it's going to be on the left-hand side. We've got headers for filters, and then I've got some subheaders for violation code, ticket status, and notice level. I don't have any code in here yet, but we will add that code in the next video, actually. Now let's go back to the website. I can see in the top right-hand corner a message that the source file has changed, and there's a button to allow me to rerun the page. This will execute all of that Python code in the script a second time, and when I click this button, we'll get a sidebar with some headers. I can't do anything with the page quite yet, but we'll rectify that in the next video. One last thing that I would like to do is create a Gitignore file. This is a file that will ensure that we don't check in the contents of our virtual environment in a Git repo. The idea of a virtual environment is that we can create this thing on any server, so we don't need to shuttle around 100 megabytes of executables and source control when we can rebuild it all with a couple of commands. So let's go to Visual Studio Code one more time, and I'm going to create a new file called .gitignore. Inside of this file, I will add 3 entries. The first 2 are actually not for Streamlit itself necessarily, but they're saying that we don't need to commit compiled Python scripts or cache contents into source control. Those are things you might need locally, but whatever application you're running can recreate those types of files from source as you execute the application. And we're now at a reasonable stopping point for this video. In the next video, we're going to hook up a SQL Server database, wire up these filters, and incorporate some visuals. And that was our overview of Streamlit. We haven't really done anything with the data yet, but don't worry, that's coming up in the next video, as demonstration me already mentioned. We'll have links and show notes in the description below, and until we see each other in the next video, take care.